Hey guys, so this first video today is going to talk you through all of the stuff you should have got from today's periodic table activity in class. So we're going to talk about nuclear charge, nuclear shielding, atomic radius, and then ionic radius. So you need to have out your packet, open to page 10, and then a pen or pencil so you can take some notes. You may also want to have out a periodic table. Okay. So the first part we're going to talk about is nuclear charge. And from your reading, you learned about nuclear charge being how much the nucleus is actually pulling the electrons in. So if we look at lithium, which has 3 protons, and beryllium, which has 4 protons, beryllium has more nuclear charge because it's got more protons to pull in. So lithium's 3 protons are all pulling on the 3 electrons that are outside of the nucleus. And the more protons that we put inside the nucleus, the greater that pull can be. All right, so now we're going to talk about nuclear shielding, which was that second property that dictates all of the rules. And shielding is how the inner electrons actually stop that nuclear charge from being able to pull the outer electrons in. So we talked about how the nucleus has a certain charge. So lithium, for example, has 3 protons, and they're constantly pulling in those electrons. Because remember, like charges repel and opposites attract. So the positively charged nucleus is attracted to those electrons on the outside. The more of these orbitals, though, that are between the nucleus and the outer electrons, the more things that are stopping that nuclear charge from being able to pull on those outer electrons. So the more orbitals that we get between the nucleus and the outside, the less we can get a pull, so the more shielding that's occurring. So, for example, here in both of these, there's an orbital between the nucleus and those outer electrons. If we go down further on the periodic table, we add more orbitals, which means there's more electrons shielding the nuclear pull from that outside electron.
Okay, now we're going to talk about atomic radius. So the first one we're going to look up is going down a column or group, right? So the 2 examples I have here are sodium and potassium. So sodium, we know that is on the 3rd row across in the first group, so it has 3 energy levels going out, okay? And potassium is on the 4th energy level, or the 4th row in the first group, okay? So it has 4 energy levels that the electrons are housed in. So when we're looking at the size of the atomic radius, remember we're looking at like how from the middle out, how far out the electrons go from the center of the atom. Okay, so here, if you think about it, even though this has more protons in it and the protons are pulling in, there's a lot more electrons in the middle layers or the inner layers that are kind of acting as a buffer. So the more energy levels we have, the further out our atom is going to get. And you can kind of see that just by looking at this picture here. So nuclear charge doesn't play a role when we're looking at the group going down. It's nuclear shielding, okay? So because we have more electrons in the center here, more energy levels as a buffer, we have a bigger atom. If you're going across a period, okay, then we're going to focus on the nuclear charge. So this one goes back to that idea of how many protons do you have and how great of a pull in towards the nucleus do you have because of those protons. So sodium here has 11 protons and magnesium has 12 protons in the nucleus. So even though both of them have 3 energy levels, okay, so their electrons are housed on 3 energy levels, the pull is greater for magnesium than it is sodium, okay, because those protons are pulling those valence electrons in. They're greater charge, the greater ratio of protons to electrons. So as we're going looking at trends in the periodic table here, okay, if we're looking at the atomic radius, as we go across this way, we are decreasing. In our atomic radius, because more protons we're pulling in. As we go down this way in a group, we are increasing. Because we are gaining more energy levels. Okay, next we're going to talk about ionic radius. So ionic radius, if you guys remember, we talked about ions when you did the periodic interactive table, and we talked about it a little bit in Unit 1. But just a reminder, so cations, remember they are the plusy cat. They are the positive ions. They're the ones that lose an electron, okay, to become positive. And then the anions were the negative charged ions, so they're the ones that gain an electron to form an ion. So just keep that in mind as we go through this. But the first example I have here is a cation. So I have sodium, and then like a normal neutral atom of sodium, and then I have an ion of sodium, so that +1 charge. And if you recall, when we get a cation, we're losing that outer valence electron. So in the neutral sodium atom, we have 3 energy levels, okay? And in the cation, I lost that 3rd energy level, that 1 electron that was on there. So if we're looking at this, we have 3 energy levels here, 2 energy levels here. We have the same amount of protons because it is sodium, so we have 11 protons in the nucleus. And if we're thinking about that nuclear charge and that like tug of war, that pull from the nucleus in with the electrons, this one has to go through 3 energy levels to pull that outer electron in, okay? So we have that nuclear charge going in. This one only has 2 energy levels to pull in, okay? So it has fewer electrons than this one does, so it has a greater pull on those electrons. You think about it like if you're walking dogs, if you're walking 11 dogs versus 10 dogs, which one's going to be easier for you to handle? Okay, so that would be the cation. So this atom here, because it has a greater pull inward, would be a smaller radius than just the neutral atom. Okay. Now, if we're looking at the anions here, we have chlorine for this example. This is my neutral chlorine atom. And then I have the anion of chlorine. So it has gained 1 electron to fulfill its octet. Okay. So here we have 3 energy levels. And over here we also have 3 energy levels. But this one has 7 electrons on the outer. This one has 8. So if you think about the proton to electron ratio here, okay, this one has 17 protons to 17 electrons. This one has 17 protons to 18 electrons. So again, thinking about like which one would have a stronger pull in, which one do the protons pull in further, and it would be the one that has fewer electrons. Okay, it's that tug of war. So they're able to pull in the electrons and make that atom smaller. And this one, there's more electrons, so they're resisting. So it's a little bit bigger than this one is. Okay, so if we're thinking about it, cations, generally, if you have a cation, it's going to be a smaller radius than the neutral atom. And if you have an anion, the neutral atom will be smaller than the anion.
Now that you've completed video 1, we want you to go in and take the formative on Power Schools. So if you go to the Unit 3 page on Power Schools and look in that middle column, you'll see a copy of this formative. You need to go in, put in the password, PlussyCat, PLUSSYCAT. And remember, you need to take that formative by 7:30 on Friday so you can use the data to run class. Thanks.